Up until now, if we had a lead coefficient on the squared term, what we usually call A, as in A something squared plus B something plus C, the first term, the first coefficient, the lead coefficient, so we refer to as A. Up until now, if A was greater than 1, it could factor out. Like we could divide each term by 5. If we did that here, though, we'd have a z squared, which would be nice, but then we'd have 16/5 and 3/5, which isn't so pretty for doing math. This is the more complex form of factoring. When you have a lead coefficient, it comes a little bit harder. All right, same concept overall, though. We're trying to factor into two separate binomials. We know there's going to be z's involved. I need a z on this side and a z on this side, so when they multiply, they become z squared. I know that I'm going to have a constant here and a constant here. The signs in this case should be pretty easy. If they're going to multiply to a positive and add to a positive, we know they're both positive. But now's the tricky part. We know that these two numbers, the two coefficients here, have to multiply to 5. Okay? We know that these two numbers here have to multiply to 3. So here we have 5 and 1. Any other ways you can multiply to 5? There aren't. Okay? How about 3 and 1? That's how you make this. That's the only way to get 3. So we have to figure out a way in which we can set this up so that they add up to 16. If I went 3 times 1 plus 5 times 1, that would be 3 plus 5 is 8. That's not enough. The other combo is that the 3 matches up with the 5 and the 1 matches up with the 1. 5 times 3 is 15. 1 times 1 is 1. 15 plus 1 is the 16. So I know that I need a 5 and a 1. Put it here if you like. And I need to make sure that the 3 multiplies by the 5. Well, the one that's in the same binomial, when it expands, wouldn't multiply by it. The one over here would. So the 5 and 3 have to be in opposite binomials in order to multiply. That leaves the other one to go right here. So our answer is 5z plus 1 times 1z plus 3. For some people, that method is easier. Some people like things that have steps, so I'm going to show you a second way to do this. If the first way made sense, stick with the first way. All you're doing is trying numbers till they work. This next one forces you into a pattern which makes you isolate the correct response. It works best if you understand how it works, but even without understanding how it works, you're probably going to be all right. Some people call this the diamond box. Okay? We're going to do a diamond and then a box. I like to call it the X box because that doesn't look like a diamond to me, but the numbers we put in will be in a diamond in just a second. That's why I think they call it the diamond box method. Okay, the way this works is up top in the X, you put the product of the first and last number, the A and the C. 5 times 3 is 15. On the bottom, you put the middle number. That's 16. Now on the sides, you have to put whatever values could add up to 16 but multiply to 15. Alright? That's either 3 times 5, which add up to 8, or 15 times 1, which add up to 16. So it has to be 15 times 1. Okay? In this example, we're talking about z's. So we need a z here and a z here, because that would add up to the 16 z's and would multiply to 15z squared, which is what happens when you multiply 5 times 3. All right. Right now you might not be understanding why we're doing this, but if you remember, it's the two numbers that multiply to the top and add up to the bottom. We're good so far. Now we're going to translate this over to this box over here. Okay, into the box we put the original first term. Okay, that goes here, 5z squared. We put the original last term down here, because what we were doing was splitting up the middle term. This is teaching us how to split up the middle term. I'm splitting up the 16z's into a 15z and a 1z. I'm going to write 15z here and the 1z here. Okay. Next step, we look across the top and we figure out what is common in these two terms. What's the biggest thing we could factor out? We could factor out a 5 and a z. Across the bottom, nothing factors out, so the biggest thing you could possibly factor out is a positive 1. Down the side this way, the numbers are 5 and a 1, so 1's the biggest number, but there is a z in both of them, so a z could factor out. Then down this way through the boxes, 15z and 3, well 3 go into both of them, a positive 3, so you could say plus 3, and that's actually our answer, right? Z plus 3 times 5z plus 1. That came from here. Is that less confusing? I have no idea. Is it more confusing? I guess it depends on the person. Some people like to just guess and check. Other people can follow this pattern, which is a long pattern. That pattern is to say the first term times the last term goes up top. Alright? The middle term goes on bottom. Then we figure out what happens, what two numbers could split up, how we could split up that 16, right? Still needs to add a 16 in such a way that it multiplies to the top. Put the original value there, our split values here and here, factor, 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 and that's our answer. It's just a path that leads us most quickly to the correct factoring of the number. Alright? While we let that soak in, let's try another example.